Good morning, everyone, especially to our panelist and our thesis advisor, Mrs. Lori Ann Caballo. Today, we will present to you our research, which is about the discontinuous fabrication of functionally graded ceramic bodies utilizing Philsaga mining waste for ceramic roof tile application. So for the outline, first, we will discuss the introduction, followed by the theoretical framework, methodology, results, conclusion, and recommendation, which will be discussed by my partner, Mr. Villarino. In building a house, roofing material is one of the most essential part. Roofing is one of the most innovative and practical creations of man. Roofing materials and fabrication methods have evolved considerably throughout history. Roof is one of the primary protective shell of a house. It only not just protects the house, but also it protects the people living in it against the external influences such as heat, cold, and wind. So in the Philippines, we all know we only have two seasons. One is the dry season where the temperature increases starting in the month of December to May, and the rainy season which generally starts from June to November. So according to Pag-asa, in the year 2019, the highest temperature recorded is 39.7 degrees Celsius, which is in Isabela, and 9 degrees Celsius for the lowest temperature, and that is in Baguio City. So all throughout the year, Philippines experience a sunny climate with an average temperature of 23.6 degrees Celsius to 36.3 degrees Celsius, in which it is appropriate to introduce ceramic roofing tiles. So ceramic roofing tiles is one of the roofing materials being used in other countries such as Germany, Netherlands, and Europe. So also in Asia, Sri Lanka try to manufacture and use CRT. However, these factories or industries were closed down, and this is probably due to not satisfying the strength and other requirements given in the standards. So we have here the different types of roofing materials. We have one asphalt, pre-painted long-range metal roofing, PVC or plastic roofing, and lastly is the ceramic roof tiles. So the most commonly used roofing materials in the Philippines by rank and type of application is the unpainted corrugated GI roof for the low-end market, which is the cheapest but would also corrode and deteriorate the fastest if not painted properly. So GI roofing or metal roofs, particularly during heavy rain or hailstorm, can be noisy. Thus, this study aims to produce a ceramic body for ceramic roof tile application as an alternative. So for our objective, we have here one, to fabricate the discontinuous graded ceramic test bar sample composed of lama-lama clay, feldspar, and treated Philsaga mining waste using the unaxial dry pressing equipment at 180 to 200 kilonewton. Second is to determine the physical properties of the green and fired formulated bodies such as linear shrinkage, water absorption, apparent porosity, and flexural strength. Lastly, is to characterize the formulated ceramic test bars in terms of its alkaline effect using sodium chloride and acidic effect using the sulfuric acid. So this study explores on various formulation for ceramic roofing tiles for ceramic roofing tile application from locally available raw materials, including lama-lama clay, feldspar, and treated Philsaga mining waste, which will help in reducing, reusing, and recycling mining waste, and this will be the answer to the high cost and limited resources of raw materials on fabricating porous ceramics. Since it is made from clay, feldspar, and treated mining waste, it is a cheap and lightweight material to effectively absorb radiation that makes it advantageous in radiation shielding applications. So for our theoretical framework, we have here figure 1, which shows the schematic diagram for functionally graded materials. So functionally graded materials are composite materials formed of two or more constituent phases with a continuously variable composition. Next, we have here this figure 2, which is the diagram of the powder pressing. So dry pressing is the most economic process for production runs and is suitable for both simple and complex geometries. So for our scope and limitation, this study focuses on the discontinuous fabrication of functionally graded ceramic bodies using the locally available materials, which is the lama-lama clay, feldspar, and Philsaga mining waste, and the green bodies are formed through a manual dry press at 180 to 200 kilonewton. For the methodology, first we have the raw material preparation, which includes the drying, screening, and pre-testing of the raw materials, followed by the formulating or mixing of powders. In this study, we have ternary composition, which includes the lama-lama clay, feldspar, and treated mining waste. So for the formulation 1, we got 40, 45, 15. For formulation 2, we got 38, 43, 19. And for formulation 3, we got 30, 45, 25. And then the best formulation will be utilized for the production of ceramic roofing tiles. So next is the dry pressing method, or the forming of the green bodies using the manual press, and then this, and also using this test bar mold. Next is, after forming the green bodies, it is then subjected to oven drying at 100 to 110 degrees Celsius and then fired at 1150 degrees Celsius using a gas kiln. Lastly is the characterization, which includes the linear shrinkage, water absorption, apparent porosity, determination of flexural strength, and then the acidic effect and alkaline effect of the fired test bars or fired bodies. So for the next slides, it will be then discussed by my partner, Mr. Ray Villarino.